We have an exciting presentation ahead of us with the great title, Don't Carry a Heavy Burden with Your Disease. 3D printing is the solution, or as a solution for that. Welcome on stage, Dr. Cora Lüders-Teuerkauf. Thank you very much.
Yeah, thanks for the kind introduction and the invitation. It's a pleasure for me to speak here at the LightCon. And in the next couple of minutes, I want to give you an overview about lightweight construction in combination with 3D printing in medicine. And let's start with a basic requirement for the lightweight construction, which is bionics. Bionics is a combination of biology and technology in an interdisciplinary approach to aim or to solve technical problems through abstraction, through transfer, and through knowledge gained from biological models. And when I say biological models, what do I mean? Biological models can be biological processes, functions, structures, materials, organisms, and as well processes of our evolution. And here you can see a couple of examples. On the right side, you see the structure of a diatom. The diatom are one of the origin organisms of our evolution. You see the water lily leaf, which lightweight structure enables it to swim on the surface of the water. You see a filigree wing of an insect, and of course, the porous lightweight structure of our bones. And also, Greek myths and the human dream of flying inspires lightweight construction with heavier outcomes so far, as the following examples will show. And just start with the materials. New materials arises new synergies. And I have chosen a specific implant, the bone implants, as an example. Currently, bone implants are made from titanium. Titanium is a metal. It's not known to interact very good on the chemical or biological side with the patient's body. So researchers from the ETH in Zurich produced a new material, magnesium bone implant. And magnesium has a couple of advantages. First, it's part of our bones, so it's biocompatible and it's resorbable. So a mold was made from a salty paste using a 3D printer, and during the process, the salt were washed out, and you received a pure, porous magnesium scaffold where the cells can grow in. And the last advantage, which is the main one, is that you don't need any further surgery if you implant this, because due to the self-absorption, you get a wound healing, a bone healing, and it's not necessary to remove the implant later on. And when we think of lightweight construction, we first think of very filigree structures or extremely lightweight construction materials, such from aviation or from racing. Or you think of the Eiffel Tower in Paris, which is also considered to be a lightweight construction. But in the last years, in the medical sector, lightweight construction together with additive manufacturing becomes more and more attractive. And there are a couple of materials available so far, which are titanium polymers, a handful polymers, and fiber composites. And they all have the advantage that they are very light. On the same time, they have a very good stiffness and strength. They are sterilizable, which is most important if you implant something, because you have to minimize the risk of contamination. They are biocompatible, and in some parts they are transparent, so they allow an X-ray or radio waves to pass them through. And of course, they are all able to fabricate and individualize a tailor-made medical product. And this is a good example for such a product. This is a vertebral body. You can insert it here in your spine to create more stiffness if the spine is diseased. Polymers, they are known to ensure a quick recovery, especially for PEEK and PEC, and to ensure a good and a better acceptance than metal within the environment of the patient's skull. Tina has also shown an implant for skulls. This is another design, but it's actually the same. You have a rough surface and a perforation, so cells can attach on the surface and grow inside, and you get a very good acceptance between the implant and the skull. Another example for lightweight construction is the zygomatic implant from the Fraunhofer Institute in Dresden. And in oral and maxillofacial surgery, this lightweight construction is used as a replacement in the jawbone here after tumor removal. So for patients suffering from cancer, this is a quite good solution to get a new piece of their bone. And we have the huge group of orthoses. You can see some of the orthoses at our booth downstairs, and orthoses are medical aids which stabilize and guide and immobilize parts of the body. And you can see here a couple of them. And for example, we have, I want to show you these helms for the babies. Some of the babies are born with deformation of the heads, and this is a head perforated, which is very good because it's comfortable to wear. It's not disturbing the baby during moving its head, and it's very lightweight. It weighs only 100 to 150 grams. So it's not such a heavy helmet like from ice hockey or something else. And you need materials to create such structures. So these are highly flexible meshes for orthotics, and they are foldable. We have seen meshes from you in the first presentation, and these meshes have the aim to imitate softer tissues like muscles and tendons, and collagen is a good inspiration for them. Collagen is a highly flexible protein with a triple helix, so this is a good idol for creating new materials. And this is scoliosis. I hope that most of you know what it is. For those who don't know, scoliosis is a deformation of the spine. It's twisted by themselves, and surrounding muscles can't do their job any longer. So patients need a brace, and braces, unfortunately, are bulky, very uncomfortable, and manufacturing of such a brace is today an almost analogous process since the last 100 years. It's not new. It starts with the screening, followed by preparation of the plaster cast and long waiting time for drying of this plaster. And then you get a brace looking like this on this right side. And if you ask patients who wear this brace, they often said, oh, it hurts, I'm sweating, it's absolutely uncomfortable, so we have to find a new solution. And 3D printing is a very good solution because you can fit it in an accurate and in an individualized design. It also starts with a screening, a remote monitoring. You can do this at home if you have only weak symptoms. If you have more symptoms, you go to a doctor. Patient's data, patient's records are trackable. Then it's followed by a digital imaging, which means there's no scary start of treatment because you don't have to wait for the cast. Everything is faster, it's more digitalized, it's more comfortable. And what you receive is a high-fashioned, of course, a high-fashioned, softened, individualized brace where you don't sweat inside when you're wearing it. And it's necessary that you wear such a brace more than 22 hours per day, so almost the whole day. Next example, what can we learn from other industries? For example, from the automotive industry. And on the left side, you see a wheel developed by Michelin a couple of years ago. This is an airless wheel. And you clearly see the lightweight structure. And this inspires researchers and orthopedic technicians to produce and to develop leg prostheses. This is the Pangolin, because Pangolin in German, Schuppentier. It looks like this. It's highly fashionable, and it won an award a couple of years ago at the Rapid Tech in the Pioneers Challenge. And they convinced the jury with the synthesis of design, fitting, and lightweight construction. And even in prosthetics, which focuses on the mobility of each individual patient, numerous aids are available, also made with additive manufacturing in combination with lightweight constructions. For example, you see a wheelchair, and do you expect the weight? Could you imagine how heavy it is? 3.9 kilogram. 3.9, which is very, very light. Yeah. On the right side, you see a pneumatic knee. It's a knee prosthesis, and which is extendable via flexible parts. So it makes a better walk, a more natural walk for the patients. Also produced with lightweight principles. And this is my last slide with examples. OR equipment, there are lamp casings, bogies, light and headlight components, or operating tables produced with lightweight constructions in combination with 3D printing. And Tina has shown the same slide, so I make it a little bit shorter. These are most of our members. We have 100 something around about 150 members at MGA. They are all actors from the whole value chain of additive manufacturing. MGA is the short version, Mobility Goes Additive is the long version. We have two branches. Tina shows this also. We have a mobility branch and we have a medical branch. And within the medical, we have 5 working groups, because our members are organized in these working groups, which are focused on the topics of their activities. And what we see is that more and more companies and more members are joining both, which is quite interesting, medical side and the mobility sides, and they benefit from each other, as you've seen here in my slide, automotive industry and medical industry. So if you want to join us, you are highly welcome. And this is an example for the outcome. Outcome is very important for us. And this is a so-called classification tree. We developed this in our approval working group, and we have chosen Annex 8 of the MDR, which is a long, comprehensive work, and we make the long story short with a flow chart, and it's easy to answer yes and no questions, and then you find the right classification class for your medical product. Of course, you have to read the MDR, yeah, but it's much more shorter. And this is my last slide, which shows that the circle is closed now. It's not necessary to carry a heavy burden with your disease, because there are so many new solutions using additive manufacturing in combination with lightweight construction. So thanks for your attention. If you have some questions, you are highly welcome. I will answer this. You will find me at our booth downstairs, or you send me an email later on. Thanks a lot.
Yes, thank you very much, Dr. Lüders Treuerkauf, for showing us a whole nother dimension of lightweight design. It's not only saving resources and CO2 emissions, which is important enough by itself, as we have learned through the past 2 days, but it's enabling life comfort, it's even a normal life, through lightweight design and additive manufacturing. I think this is very impressive if you think about it, if you think about the people affected, and then through solutions like this, what change it can mean. I think it's very impressive.
Of course, it improves the treatment
Yes.
by individualization.
Yes, exactly. Are there questions from the audience? Well, I
Your
do have a
question.
question, of course. I'm curious, again, I have to ask about the design, because looking at all these amazing grid-like structures, I mean, in the end, the natural examples you've shown, the water lily is a grid structure, the wing you've shown is a grid structure, and many of the additive manufacturing results are grid structures. How do you get, or how do your members in your network get to the right design? Do you have experts, engineering companies for that? Like, I'm just curious from my engineer's perspective. I know topology optimization, the flow of forces through the structure, what material do you actually need? Is that playing a big role? Are there specialized software tools for? I mean, there's the third question now, but are there specialized software tools? I'm very curious about that.
A very good question. It's an interdisciplinary work. You need biologists, you need the technicians, you need the software experts, and bring all the minds together. Then you have to open your mindset. You have to think totally different, not only conventional. You have to think different. You have to think more individual. You have to check how patients are moving, and then you will find the solution for this. But it's a teamwork. No one can do this alone. It's a teamwork.
Yes, I didn't even think about the individualized moving apparatus of people, and I was only looking at the
and of
at
course
the forces.
there are
Yes,
experts
yes.
in the network
Yes, okay.
Supporting the design process as well as the manufacturing process.
And then you can go back to the technical side and look at machines and movements, etc.
Yeah.
And probably, as you've shown already as well,
It's a long
transfer the
process.
data.
It's a long process, and we have learned that we don't speak the same language.
Yes, that's
Surgeons speak another language than engineers, and technicians from the orthopedic side also speak another language, and you have to combine this, and then you will have success.
So it's a great thing that you have a network where you can do
Of
all
course.
that, and the working group. So
Yeah.
if you're interested in that, feel free to contact MGA downstairs.